In this lesson, we're going to be talking about a converse. Oh no, not these kind of converses. The converse of a conditional statement exchanges the hypothesis with the conclusion. Let's take the statement, if it is raining, then there are clouds in the sky. When you write the converse of a conditional statement, what you want to do is you want to take the hypothesis and put it in the conclusion spot, and you want to take the conclusion and you want to put it in the hypothesis spot. And once you've done that, then you've written a converse. So the converse here would be, if there are clouds in the sky, then it is raining. Now, statements can be true or false, and their converses can be true and false. You can have a statement that's true and a converse that's false, and you can have a statement that's false and a converse that's true. So you can't just assume because a statement is true, its converse is true, or vice versa. So let's talk about each of these and determine if they're true or false. Well, when we make the statement, if it is raining, then there are clouds in the sky, let's look for a counterexample of that. Whenever it is raining, there are going to be clouds in the sky because the rain comes from the clouds. Now, I don't want you to think along like absurd lines like, well, I was, standing in a sun shower and there were no clouds. The rain comes down from the clouds. So if it is raining, then there has to be clouds in the sky. You're not going to be able to find a true counterexample for that. So this statement is true. Now, this statement, the converse, if there are clouds in the sky, then it is raining. We could easily think of a counterexample from that. For that, yesterday it was cloudy, but it wasn't raining. So this converse is false. So we need to be able to evaluate when statements are true or false and converses are true or false. If they are both true, then we're able to write something that's called a biconditional statement. So, when a statement and its converse are both true, you can write them as a single biconditional statement. Let's take a look at an example of this. So, let's take the conditional statement, if an angle is a right angle, then it has a measure of 90 degrees. That's a true statement. It's a true conditional statement. You're never going to be able to find a counterexample of a right angle that does not have a measure of 90 degrees. So, why don't you pause the video and try to write the converse of that statement. So here's my converse. If an angle has a measure of 90 degrees, then it has a right angle. One thing that I want you to notice here is you may have written the statement if it has a measure by just moving this back to the hypothesis spot, but you really need to keep the subject in the beginning. So if you're talking about if an angle, even though literally if you just moved it has a measure of 90 degrees, your new conditional would be if it has a measure of 90 degrees. You want to leave the angle part so that you have the subject in the beginning. So if an angle has a measure of 90 degrees, then it is a right angle. So we already talked about how the original conditional statement was true. Let's talk about the converse. If an angle has a measure of 90 degrees, then it is a right angle. You're not going to be able to find a counterexample for that, so we're going to have to say the converse is true as well. So we write the biconditional statement like this. An angle is a right angle if and only if it has a measure of 90 degrees. Notice that we did not include the if or the then. Those get eliminated when you write a biconditional statement, and you always have if and only if in the beginning. Or, I'm sorry, in the middle. An angle is a right angle if and only if it has a measure of 90 degrees. So it's important to note you can only write a biconditional statement when the original conditional statement is true and the converse of the conditional statement is true. If we go back to this example, if it is raining then there are clouds in the sky, the converse is not true. So it would be inappropriate to write a biconditional statement here. However, if you were to write a biconditional statement here, it would say, it is raining if and only if there are clouds in the sky. So we have a valid definition when both the conditional statement and its converse are true. Let's take a look at the last example where we were talking about right angles measuring 90 degrees. Remember that We had the conditional statement, if an angle is a right angle, then it has a measure of 90 degrees. That was true in the converse. If an angle has a measure of 90 degrees, then it's a right angle. That was also true. In this case, we have a valid definition. Right angles measure 90 degrees. Let's talk about a situation where we don't have a valid definition. Let's take the conditional statement, if two angles form a linear pair, then they are adjacent. So if we were to sketch a linear pair, it would look something like this. And that is true. If two angles form a linear pair, then they are adjacent. They share a vertex and a ray, and they have no interior points in common. Let's take a look at the converse of that. If two angles are adjacent, then they form a linear pair. Well, let's make some adjacent angles here. We've got an angle next to another angle, so we've got two adjacent angles. Do they form a linear pair? No. So we have the situation where the conditional statement is true, and now down here the converse is false. And if that's the case, we do not have a valid definition. Doesn't mean this statement up here is not true. It is. If two angles form a linear pair, then they are adjacent. That's true. But since the converse is false, we don't have a valid definition, which means we should not write a biconditional statement here. If we were to write a biconditional statement, it would say two angles form a linear pair if and only if they are adjacent, but that's not true, so we're not going to write a biconditional here. So these guys go together. If you have a valid definition, you're going to be able to write a biconditional, and if something is written as a biconditional, then it's also going to be a valid definition.